So this is going to be a more challenging question to the 4 different types of concentrations. Household ammonia is a 6% solution in water and has a density of 0.973 grams per milliliter. Express the concentration of solution in molarity, molality, and mole fraction of NH3. So we know that NH3 is a 6% solution in water. The density of the solution is 0.973 grams per milliliter. The mass percent is 6%, and we know that mass percent is equal to the number of grams of solute over the number of grams of the solution. And this is what we know of the two molecules. We know that NH3 has a molar mass of 17.0304 grams per mole. We do not know the mass or moles of NH3. And for H2O, we know that the molar mass is 18.0152 grams per mole, and the mass in moles we don't know. I use mole last just to hurry up and speed up the writing. And as I was about to finish writing over here, we know that mass percent is the number of grams of the solute over the number of grams of the solution. And for density, it's the grams of the solution per milliliter of the solution. So, because we don't have a quantitative number, they're all ratios, which is 6% of mass percent and a density. We do not have a quantity of water or NH3. We need to make an assumption. But what do we assume? When we look at our two ratios that we have, what could we assume that could probably satisfy both? We have the volume, which can only satisfy this part. We have the number of grams of the solute, but it only solves for this area. But the number of grams of solution solves for this area and as well as this area. So if we assume (1,000 grams of the solution), we can satisfy both fractions. So for mass percent, we have 6%, which is equal to the number of grams of the solute over the number of grams of the solution, which we know is 1,000 grams. So now we need to isolate this. So, well, first of all, I forgot to add the multiplication of 100%. That's the first thing we get rid of. So we get rid of the percentage. We divide it by 100%. And so now we get 0.06 is equivalent to number of grams of solute all over 1,000 grams of solution. And now we bring this side over here. So 1,000 grams multiplied by 0.06. I should have this memorized, but unfortunately I don't. It would give us 60 grams of solute. And solute, we know, is NH3. So we can write it over here, 60 grams. And when we divide it by 60 grams by 17.0304 grams per mole, we can find that the moles is going to be 3.523 moles of NH3. Now, because the solution is 1,000 grams and we have the amount of mass of NH3, we can solve for the mass of H2O. So 1,000 grams of solution minus 60 grams of NH3. Well, this will give us 940 grams of H2O. Now we can put that back to the top. The mass of water is 940 grams. And if we divide it by the mass by the molar mass, we will find out that the amount of moles of water is 52.178 moles. But there's still something missing. We need the volume of the solution. How do we figure out the volume of the solution? With the density that we're given. The density given was 0.973 grams per milliliter. So now that we know the amount of grams we have of the solution, keep in mind that the density is given for the entire solution and not just the solvent and or solute. So the density given was 0.973. And the grams of the solute is 1,000 grams, as we assumed. So 0.973 grams of solute divided by milliliters of solute. Solution, sorry. The terms are just so close together. Solution. Here as well, solution. Is equal to 1,000 grams of solution over an X amount of milliliters of solution. So we can multiply both sides by X milliliters of solution, and then from there we can divide it by 0.973 grams of the solution. So it would look something like this: X milliliters of solution is equal to 1,000 grams of solution divided by 0.973 grams per milliliter of solution. If we solve that, we have 1,000 divided by 0.973. It will give us the amount of milliliters, or the volume in milliliters. So volume is equivalent to 1027.749 milliliters. We can divide it by that by 1,000, which will give us 1.027749 liters. So now we have the volume, which is 1.027749 liters. So now we have everything we need to calculate the molarity, molality, the mass percent, well, mass percent is already given, and the mole fraction. So in case you guys have forgotten, to calculate molality, it is the amount of moles the solute over the kilograms of solvent. The molarity is equal to the moles of solute over the volume of solution, and the mole fraction is the moles of either solute or solvent, or over the total amount of moles in the solution. I'll let you guys figure that out. And just for the answers for this question, the molarity is going to be 3, that's a screwed up 3.43 moles per liter. Moles is N, not M. Don't be like me. We'll just put MOL. Moles per liter. The molality is going to be 3.75 moles per kilogram, and the mole fraction is going to be 0.0633. If you have any questions about this question, or if you think something was wrong, please message me. Otherwise, thank you for watching.